Students, we have learned that an electric current flowing through a conductor produces magnetic field. The field so produced exerts a force on a magnet placed in the vicinity of the conductor. French scientist Henri Ampere suggested that the magnet must also exert an equal and opposite force on the current carrying conductor. From this, we are going to learn a force on a current carrying conductor in a magnetic field. The displacement of the current carrying rod in the activity suggests that a force is exerted on a current carrying conductor when it is placed in a magnetic field. It also shows that the force exerted on the current carrying conductor depends upon the direction of the current and the direction of magnetic field. Experiments have shown that the displacement of the conductor is highest, or the magnitude of the force exerted is highest when the current carrying conductor is kept right angles to the magnetic field or the direction of magnetic field. In this condition, we can use a rule to identify the directions. That rule is famously known as Fleming's left hand rule. According to this rule, stretch your left hand first three fingers mutually perpendicular to each other, in which the forefinger indicates the direction of the magnetic field, center finger indicates the direction of the current, and the main finger or thumb finger indicates the direction of the mechanical force experienced. The simple way to remember the Fleming's left hand rule is forefinger field, center finger current, main finger mechanical force. Now let us understand the working of an electric motor and the construction of electric motor. Before going to that, we have to define what is an electric motor. An electric motor is a rotating device which converts electrical energy into mechanical energy. It consists of a rectangular coil ABCD, which is mounted between two powerful magnets N and S in such a way that the arms AB and CD are perpendicular to the magnetic field. The free ends of the coil are connected to two halves R1 and R2 called split rings. The inner side of the split rings are connected to an axle. The outer side of the split ring are kept in such a way that it touches to the brushes B1 and B2. And these two brushes are together connected by a battery and a switch. The split ring along with the rectangular coil is called armature. Now let us understand the working of an electric motor. Current in the coil ABCD enters from the source battery through the conducting brush B1 and flows back through the conducting brush B2. Notice that the direction of the flow of current in the arm AB is from A to B, and in the arm CD it is from C to D. By applying the Fleming's left hand rule, we can identify the direction of force on a current carrying conductor which is kept in a magnetic field. If you understand, by keeping left hand near to the AB side, that is like this. This is the direction of electric current moving this way, and this is the direction of the magnetic field. Then the force exerted downwards. If you apply in the arm CD like this, that is in the direction of electric current, and this is the magnetic field, and this is the direction of mechanical force experienced. So here in this way you can identify the mechanical force experienced downward, and here you can identify the mechanical force experienced upward. So the arm AB is pushed downward, the arm CD is pushed upward. So it starts moving in the anti-clockwise direction. So as it completes halfway, the brush B1 and B2 are stationary and the axle is mounted with the split ring. As the split ring consists of two halves, R1 and R2, now half away R1 touches to the B2 and R2 touches to the B1. Now the current starts flowing in the direction DCBA. Now by applying Fleming's left hand rule again to the arm CD, that is in this way, CD moves, that is in the direction CD the current is flowing, and this is the direction of the magnetic field and this is the force experienced. Now the arm CD goes down and in the another side AB, that is this is the direction of current, this is the magnetic field and this is the mechanical force. The arm AB goes upward and the coil starts moving in the anti-clockwise direction again. So in this way, every half of a cycle, split rings are interchanging the pressures and making the current to flow in the only one direction. So this makes the motor to move in only one direction. Noise reverses the direction of flow of current in a circuit is called commutator. The reversing of the current is repeated at each half rotation, giving rise to a continuous motion of the coil and as well as axle.